Hey everyone, on this lesson we are going to learn the steps that we need to follow to use the locally linear embedding algorithm. Remember, this is a dimensionality reduction algorithm, that is, we have a data set with high dimensionality and we want to reduce these dimensions. So the way this works is that this algorithm is going to project the same data but now into a lower dimensional space, preserving the distances between neighbors. So for each data, we'll calculate the neighbors. We have here as an argument this value k, and also the value and number for the desired dimensions. And the way that we do this is the following. First, for each data that we have on the data set, for each instance, we are going to find the first k nearest neighbors in the original dimensional space. This is basically the original dimensions that we have on this data set. Once we have this k nearest neighbors, we are going to approximate each of the data by a linear combination of these neighbors. Remember that these weights, okay, each weight that we assign, if we sum all of the weights for given data, this needs to be equal to 1, okay? So as we can see here, each weight is a proportion and the sum of all the weights for given data is equal to 1. Also here it is important that the k nearest neighbors that we find, this value k, is less than the original dimension space that we have. And so now to find this new data on this new dimension space, let's just call this new data y with subindex I, which is the same subindex that we have here on this data on the original dimension space. Then to find this y, we need to minimize the square distance between this new value y with subindex I when we subtract the approximation of the weights. And this is essentially it. We can see an example from a two-dimensional space into a one-dimensional space. Also something that we have not mentioned but is important is that the eigenvalue decomposition can be used to calculate the coordinates. We will see this when we get to the project of the linear embedding and the locally linear embedding. So as we can see, initially we have this data. We calculate here the three nearest neighbors. In this case it is this one, and this one. Here we have the weight 1, the weight 2, and the weight 3. So we have one weight for each neighbor. The weight depends directly on the distance of this data and this data that we're calculating, right? So this data here is this data xi. So this is going to be an approximation of each of the other datas, basically the neighbors, multiplied by their weights. And at the end, we will have this same data, but now on this new dimensional space with only one dimension. And this new dimension, this same data, is going to be an approximation of the summatory and the summation of all the other datas multiplied by their weight in the same way, but now in this new dimensional space. So as we can see, this method preserves the distances between the neighbors. Now on the following lessons we will apply in practice this method, this locally linear embedding algorithm, to reduce the high dimensionality of a given dataset.